Good evening, everyone. Today's session is on structures in C programming, right? So, all of you have understood in my previous lecture what are structures, what are the different types of structures we have, what is the need of structures. So, today I'm going to show some examples how to create structures using C language. What are the different syntax we use for creating those structures? How to use the member variables that are specified in structures, how to have variables in our structures, how to call, how to access the member variables of a particular structure. So let us begin with the session. So first of all, before moving into the syntax part, we must understand what is a structure. So structure is a collection of one or more variables, typically of different types, not of same type. So they have the heterogeneous types of data. The types of data is not homogeneous. The type of data is heterogeneous, grouped together under a single name for convenient handling. So, like we are making a structure, within that structure there are number of variables, right? The member variables of that particular structure that may be of any type, right? And we use a keyword that is struct for creating a structure in C and C++. So let us see the syntax of that. First, you need to write struct. This struct is a keyword and then name of the structure, right? Then start the scope of this structure, start the block of statements of this structure with this braces and then write the names of variable 1, 2, 3, the member variables of that particular structure. And because it's a heterogeneous collection of data, the heterogeneous collection of variables, the variables can be defined of any type, right? And then we close the structure and define the variables which are going to access these member variables, and then we put the semicolon. So this is a defined syntax for structures, how we define the structures, right? We cannot change it. We cannot write struct without starting struct. We write just the structure name and defining the variables or creating the variables. No. So there is a predefined syntax for that. You need to define it as with a struct keyword, then space structure name, then provide the number of variables, whatever the number of variables you may have, and then just close that scope and give the structure variables, those who are going to access these member variables. This is how we create structures, right? Now let us have some example. Let us create and let us see what are the examples of creating a structure, right? So we have defined a structure of student, and this student structure is containing the name of the student, the age of the student, the branch of the student, and the gender of the student, right? And let us see first of all the syntax part of this, then I am going to explain it what this structure is showing. So this part, basically this is a keyword that is struct, space, this is the structure name, then you define the scope with this parenthesis, then define a variable, member variable, that is array, and it is the name of the variable is name and it is of type character. Then we have defined another member variable, that is age, and the type of that age is integer. And then we have taken the branch, or you may say the program, like BTech CSC, BTech IT, or any branch you are taking. So you may specify in this particular member variable. Then we have character, gender. So why we have not taken it as an array? Because gender we have already specified in a comment type of thing. This is double slash are used for comment, for just referencing the later sentence, right? So we are saying that F stands for female and M stands for male, right? So only single character is required, no need to have an array. and then just close the parenthesis and give the semicolon. So this is how we define a structure. Now let us understand the same thing. Here the structure student declares a structure to hold the details of a student, which consists of 4 data fields. 4 data fields you may say, or you may say it member variables, right? So the data fields are name, age, branch and gender. These fields are structure elements or members. That's what I told you. They can be treated as a member variables. They can be treated as a elements. Each member has different data type. I told you structure is a collection of heterogeneous data type, heterogeneous elements. Means homogeneous में all are not characters, or all the variables are not integers, all the variables are not float, because we have a structure, it has the capability of holding all the data types. So each member can have different data type. Like in this case, name is an array of character type, age is of integer type, etc. Character type, then we have branch, right? Like branch is a character type and branch is an array of character type. Gender is a single character, so no need to specify it as an array. Student is the name of the structure and is called the structure tag, right? So the name of the structure is your student. Declaring a structure variable. Now we have not declare a structure variable. So you may specify the structure variable here also. So before ending this structure, you may define the structure variables within this semicolon only. Right? V1, V2, V3 and then semicolon. This is the one method. Or why we have structure variables? To access the member elements of the structure. Right? So let us understand this thing. It is possible to declare the variables of a structure either along with the structure definition or after the structure defined. So you may have two options. I will be showing you how we define using both the ways. Structure variable declaration is similar to the declaration of any normal type of variable of any other data type. Structure variables can be declared in the following two ways. So what are the two ways? Let us see. So the first way is declaring structure variables separately. Need not, you have not specified here, right? Here within this particular scope, like I can show before this, right? What you have done after declaring, after completing your structure, next line you are declaring struct, again the structure name and space the variable names, right? Which are going to access the name, age, branch and gender, right? Second way is like this, completing this part and then S1 comma S2. So this is how we are having two variables before like completing this structure. Within this structure we may define it. I have closed the member variables and then after this we have defined the number of variables. Now how to access these variables? Another syntax is how to access this variables. Before doing that, we have not defined S1. We may define it here, that is S1. Then within main function, this is how to assign a value to a member variable, right? This is how we assign a value to a member variable here. Like S1 dot age is equal to 18. Now in this structure we have the same fields, the same member variables we have defined the structure variable as S1 and now S1 dot age. So dot is the operator which is basically the linkage between the structure and the structure variable, right? And then it assigns some value, whatever value you want to get in particular variable, right? So which operator? That is the dot symbol that is used to connect between the structure and the structure variable. Then we have a structure initialization. Like suppose I want my p1 variable should hold this kind of value, or I may be defining it in another way. So let us see that part also, how we initialize the structure, right? So structures like a variable of any other type, another the structure variable can also be initialized at compile time. So you may initialize at compile time. How to initialize that? You have defined a structure that is patient, and these are the member variable 1, member variable 2, and member variable 3. Now after that you have defined structure, patient, and variable, right? Now this variable would be holding the values under height, weight, and age, right? So how to write it down? Just open the parenthesis and write down all the values. It is going to assign like this. First is height, that is a floating point number. Second is int weight, that is an integer number. Then is int age, that is again an integer number. This is how we are going to assign or initialize the values in the structure. This is one way. What is the second way? This is the second way, right? The second way to initialize the values of the data variables in the structure is, you may access that particular variable dot, like I have shown you in the previous slide, s1 dot age, right? So here we are using p1, p1 dot height, p1 dot weight, and p1 dot age, and then one by one you can write it down the value also. So this is how we initialize the structure with some values, right? Then we have, it's a struct. Now let us see what is struct, and I have taken some more examples to make you understand how it works actually, and different data types can be taken while defining a structure. So struct keyword is used for defining a structure, and we have defined another structure, that is motor, and that is having the values like float volts, voltage of the motor, amperage of the motor, amps, phases of the motor, and rotational speed of the motor, right? And we have specified these variables, these member variables within a structure called motor, and then we just close it. Now again, this part we have used, like it is defining and what? Nothing. Once you have defined these thing, a structure is defined, right? Then we have what are structure variables that we have just now completed. Let us understand with this example also. Struct motor PQR. So there are three variables that is of type that may access the member variables of motor, declares and sets aside storage for three variables, that is P, Q, and R, each of type structure motor. What is the type of these variables? That is of structure, right? And suppose another unit I have defined, struct motor. I have taken one array of 25 units that allocates 25 units of storage. So we can enter 25 elements in that particular array. That is of structure type only. Declares a 25 element of array of structure motor, allocates 25 units of storage, each one big enough to hold the data of one motor. Okay, so we have defined the 25 units. Again, we can also define a pointer to an object, that is by using the asterisk. Right. So again, we have different implementations of variables also. We can take it as variable. We can take it as pointer to that particular variable also. Or we call it as pointer to object. Right. Then we have is accessing data members of our structures. Like how to have access on that particular member variable using a variable. So this is the structure we have. Okay. This is the motor structure, and we have defined one variable, that is P. Right. Now this P is going to access all the member variables of the structure, that is motor. right? So P dot volts is the voltage, P dot amps is the amperage, P dot phases is the number of phases, P dot RPM is the rotational speeds, right? So this is how we access the different variables, the different member variables of a structure, right? I hope you have understand each and every concept, because the first concept that I have told you about how to define variables, it can be defined within the after that closing of that parenthesis of structure. Why there is a need to have another method, like we can, this is the second syntax for defining the variable. Now let us see the pointer concept, right? Let struct motor and pointer to an object, that is P. Now this P is going to have the value, how it is going to have the, how we are going to access this member variables P, then arrow. Now basically, while using a single P, let me tell you, if we are using it as a simple P variable, if we are defining it as a simple P variable, then this dot operator is used, right? Whereas when we have declared, when this variable is declared as to like pointer to an object, we have to use this arrow. So this is the difference between both the variables, a pointer to an variable and a simple variable. So there is a difference between both of them. If you are using this as simple P, then directly you can access this, like P dot volts, P dot amps, P dot phases, P dot RPM. But when you have same syntax, you have pointer to this object, you have to specify it as an arrow. P, not dot. To do, don't get confused, when we are defining it as a single simple variable, dot operator is used. When you are defining pointer to an object or pointer to a variable, you have to define it as arrow. And how to use this arrow? You have a symbol of dash, right? You have a symbol of dash on your keyboard, right? And then just print the greater than sign. So this is how. There is no such symbol on your keyboard. You need to combine the two things. First is dash, that is after 0. You may see this symbol dash coming after 0 and greater than sign coming after m less than n greater than sign, right? So the single symbol is not on the keyboard. You have to make it while using the this symbol, right? While using the pointer to an variable. Okay. So I hope you have understood the concept of structures, how to initialize the members of structures, how to define structures, how to use structures, what are the advantages. Before going into the why we have structures, let me tell you structure is one of the data, like why we are using that. It's a heterogeneous collection of data, first of all, and the symbol is very easy to use, right? It is very simple to use the structured data type, and you, the symbols, the syntax is also very simple, right? Like we have in our structure, only struct keyword is used, struct space structure name, then you can define the member variables, and then you define the variables within the structure, and then you can access these member variables with the help of two things, dot or arrow key. If you are using dot, that means the variable is a simple variable, and if you are using arrow key, that means we have defined the variable as a pointer to a variable or pointer to an object, right? You may call it like this also. So these are the some examples, these are the points that needs to be taken while defining the structures. right? Like suppose I want to define a structure, right? I may be writing the syntax like this: struct, and then defining it as a variable, then defining the variable, and then defining the number of member variables. Now, can you distinguish with array? Yes, we can distinguish with array. When we talk about structures, structures are heterogeneous collection of data. You may have data, you may have member variables that could be of any type. You may not have the variables which is of same type. If it is of same type, why not you use array? So when you have structures, you may define it number of data types. Like you may use number of data types. The data types could be different, right? Whereas in terms of arrays, we can have only a homogeneous collection of data types only. So, and in structures also we have number of options through which we can define how to call this structure with a simple variable or pointer to a variable, right? So there are number of advantages behind it, how we defined a structure. So let us see why we use structures. Open-ended data structure. This is a open-ended data structure. Structures may grow during processing. So you may increase the elements also. You may increase the expand the elements also with the help of, like, wherever you are defining the structure, just define those variables. So where you have defined it here, right? You have defined number of variables here. This is member variable 1, member variable 2, member variable 3, member variable 4. If you want to increase it, you may increase it here. You may add the number of variables, member variables here only. Now once you have added, you may access it with the help of variable and pointer to object. Right. So there are two things how to access these member variables, either with the help of variable or with the help of pointer to the object. Right. Now, avoid the need of reallocation, reloc, and lot of copying. So you need not have to copy anything in this. Plus reloc function. It is like it can avoid that reallocation of memory, right? Self-referential data structures. So you may have list, you may have trees, etc. So they are self-referential data structures, right? So I hope you have understood the concept of structures, and I have related it with arrays also, how arrays are useful. Arrays are useful when we have a homogeneous collection of data. Like in this example also, I have given the array also. Yeah, name 25 subscript. What is the size of array? That is 25. So we have used it as a like name with number of characters. The size of this particular array, the name could be of how much size? That is 25. So or the branch could be of how many characters? That could be 10. So we may specify the size at the time of initialization of variables, right? At the time of declaration of variables, right? When you are going to initialize, this is the initialization part. When you assign some values to that particular member variables, right? So when we have initialization part, we may directly assign the values to the particular variable. Whereas when we have declaration part, we only declare it. Here we have declared it, and then after that we have initialized it. So there are two ways of initializing the member variables. One, we are assigning the variables before, like once we have done with our variable declaration, like struct, patient and patient1. Now you can give the values at this time only. Or You may do this thing after like you have declared it, like in the second method what we have done. Once we have declared it, now we are just using dot operator, we are assigning the values like p1 dot height, p1 dot weight, p1 dot age. So after declaration of that particular variable, now we are going to assigning the values. And with the same with the pointer also, when we have pointer to an object, first we have declared that pointer to an object, and then we assign the values like p, that is arrow walls, is equal to whatever the number you want to give. Then p arrow phases equal to what are the number of phases you want to give. So here both the syntax would remain same. The only thing is there you use dot operator, dot symbol. Here you use arrow symbol. So this is the only difference between when we are using it as a single variable and when we are using it as a pointed variable. Now, the last thing I want to make you understand is when we are using structures, we may create, like in C language also, we may use these structures. There is also a concept of union, right? So there is the union are same as this, but there is a difference between them in the memory allocations. So I will be giving a session on this also, like how to create unions, that is again another data structure. And then I will be discussing how the memory part is different in this structures, and how is memory allocated with unions are different from this structures, right? Both are advantageous, but what is like when we use structures and when we use unions, once you have understood the concept of unions, then I can tell you how the memory allocation is done with structures and how the memory allocation is done with unions, right? Now in data structures, like we have arrays also. Array is a, like I may tell you about the array part. Array, when we have an array, like you have given 25 or whatever number you have given consecutive, it allocates the memory consecutively. And again, the disadvantages, all the data that are stored in that particular array should be of same type. Like if we are taking the value of integers, we may take it all the values as integer only. So this is the disadvantage why we have the concept of structures. So in structures, we can have multiple values, multiple types of data within a single structure. Within a single structure, we may have different types of values, right? So this is the difference between arrays and structure. So each data structure has its own advantage. When we have to maintain some data that is containing all the numbers, so maybe using array. But the disadvantages with array is once you have specified the size of an array, it is allocated in the memory. So wastage of memory would be taking place while using arrays, right? So this is the disadvantage. So structures, I will be telling you what is the disadvantage of structures in comparison to unions also. So we will be, I hope you have understood this session and you like this session. In another session, I will be telling you about what is the difference between structures and unions, how they are related to each other, and how they are different from each other, right? So thank you.